The question that I left you with in class, and I was pretty keen just to help you through this one, and then there's a couple more you can practice on. So just to continue with this question, we've got this polynomial here that I want to divide by x plus 3. So I set up my division, x plus 3 into, and then I'll whack in my cubic here, 2x cubed minus x squared plus 3x minus 1. All right, now here's the process. Leading term, 2x cubed, divided by leading term x. That's 2x squared. Okay, lock that in. Now, 2x squared times x plus 3, and we imagine x plus 3 is in brackets. So this is what we're imagining. We're imagining this, 2x squared by x plus 3. So I'm doing this multiplication, and I'm writing the result just beneath here so that I line my 2x cubed up. These two guys always are the same. These guys here, always the same. All right, that leading term has to cancel. All right, back to work. What have I got? Plus 6x squared here. Okay, so now I'm going to subtract. So I'm subtracting 2x cubed plus 6x squared from 2x cubed minus x squared. So this can be a little hard to visualize as well. So I'll just write down what we're doing here. We're going 2x cubed minus x squared, and we're subtracting 2x cubed plus 6x squared. Now we'll get to the point where we don't need to do this, but that's fine at the moment. So the 2x cubes cancel, and we end up with negative x squared minus 6x squared, which is negative 7x squared. So I write that down here, and that is the completion of one loop. Now we're going to repeat that. That's what an algorithm is. There's a series of steps that you just keep repeating. So I've got minus 7x squared here, and now I take it and divide by x, and I get that minus 7x. Oh, the other thing I'm going to do now is I'm going to bring that plus 3x down. Let's recruit him. This is where we left the question in class. So negative 7x goes in here now. Off I go. Negative 7x times x. There's those guys cancelling out, just as we wanted. And now it's negative 7x times 3, so I've got negative 21x here. Now I'm going to subtract 3x minus, I've got to imagine I'm subtracting all of this now, right? So 3x minus negative 21x. So I'm subtracting a negative, that's an add. So that gives me 24x. Let's bring down the negative 1. And now I've completed 2 iterations now. Now I want to write a number here that when I multiply back through, I get 24x. So 24x minus x, 24x divided by x is 24. So that's my last term up here, 24x. I multiply through 24x plus 24 threes are 72, I believe. Subtract. Negative 1 subtract 72. It's negative 73. And now this degree, that remainder there, I'm now left with a number, a term that's got a lesser degree than what I'm dividing by. So I now stop. That's my remainder. Now, so what I've got is, they want me to write it in this form here. So my px, which is this fella here, the 2x cubed, so I'm going to write it in the form they want it. Therefore, 2x cubed minus x squared plus 3x minus 1 equals x plus 3, which is what I was dividing by. The qx is this result up here, 2x squared minus 7x plus 24, 2x squared minus 7x plus 24, and then I've got this remainder, rx, which is negative 73. All right, and I'm just going to write it like this. So that's my result. All right, so the division, I've divided 2x cubed minus x squared plus 3x minus 1 by x plus 3, and I got this. I just want a different highlighter pen. I got this. All right, that's the result of the division. That's the result of the division, and then the remainder is here. All right, so the result is 2x squared minus 7x plus 24. That's the whole amount that was left. And then this negative 73 was the remainder. That's what was left over. So that's how we write it in the form that they've asked us. I could have just as easily, it means the same thing, to write 2x cubed minus x squared plus 3x minus 1 divided by x plus 3, right? That divided by x plus 3, well, that's equal to that thing in green, 2x squared minus 7x plus 24, right? That plus negative 73. Right? That's what's left over. And then I've got the plus minus negative 73. So this is what we call the QX, the quotient, and then this is the remainder. Okay, so I'm now going to ask you to do these questions down here. All right, these ones here. Might be a good idea now, maybe, what are we up to, 5 minutes. Pause this video and attempt part A, right? Pause the video and do A. And then restart it, because what I'll do now is I'll write a solution for A, and then you can check your answer against what I am carrying on with. So press pause, and I'll see you in a minute. Okay, so you've had a go at part A here now, so I'm going to do that question. I'll go through it step by step, and then you can check your answer. And if you're pretty confident, you can double speed this maybe so that you can whip through to the end. Okay, off I go. X cubed divided by x, so I put an x squared in here. X squared times x minus 1. I'm going to be quiet now and just do this in silence. Negative 4x subtract negative 2x, so that's negative 4x plus 2x. There's my remainder. So px is equal to x minus 1 by qx, which is my x squared plus 2x minus 2, plus 1. Right, we're done. Now, now have a go at B and do the same now. Pause the video and come back to check your answer. Okay, I'm now going to do a solution to B. Three x cubed in here. Divide that by x plus 2. Okay, so you're checking your homework now. All right, so 3x cubed, I am dividing that by x to get 3x squared in here. Now I multiply out 3x cubed plus 6x squared. Give myself a bit more space here. Subtract. Negative 2 subtract 6. Careful, negative 8x squared. Let's bring down that plus 5x. And I am now negative minus 8x. Subtract 5x, subtract negative 16. Positive 21x. Bring down the minus 2. Plus 21 here. 21x plus 21x plus 42. We're subtracting. Negative 2 subtract 42 is negative 44. So therefore my polynomial, cubic polynomial, is equal to x plus 2 by 3x squared minus 8x plus 21. And then I've got this remainder of 44, which I kind of like to write like this. All right, I'll see you guys in class tomorrow. I can work out how to stop this video. Oh, there's the button up there.